Hello and welcome one and all. Today we are going to build a Retrieval-Augmented Generation app using langchain and ollama. You can then use this app to interact with your documents. This application is great for when you have a collection of books, documents, and you want to be able to interact with that data using AI. For example, you might want to be able to ask questions about that document and get an answer, or perhaps build a customer support chatbot that you want to follow a set of instructions. We are going to build this using ollama and the langchain library in Python using a local LLM. We are going to be using a technique called RAG, which stands for Retrieval-Augmented Generation. In this example, we are going to use a PDF as our data source. The agent will be able to use that document to give me a response as well as quote the source where it got that information. This way, you always know that it's using data from the sources we have provided. If this project sounds complex, don't worry, it's a lot easier than you think. I'll walk you through every step of the project, starting with how to prepare the data that we are using, and then how to turn that into a vector database. Then we'll look at how to query that database for retrieving relevant pieces of data. Finally, we use an LLM to put all those pieces together to form a coherent response. Let's get started. To begin, we'll need a data source like a PDF or a collection of text or markdown files. It can be a customer support handbook, employee handbook, or any documentation you want to analyze. We will use Jupyter Notebook as our development environment, and we use the langchain and langchain community libraries. We are using SQL Server's SQL recipes in a PDF document. We have to split the PDF document since it is a long continuous document. We use the PyPDF loader module to load the PDF document. From this module, we use the load and split to split it into manageable pieces. We further break this down in not smaller chunks. A chunk could be a paragraph, it could be a sentence, or it could be even several pages. It depends on the chunk size. This exercise provides us with a small chunk that is going to be more focused and more relevant to what we search for. To achieve this, we can use a recursive character text splitter. And here we set the chunk size in the number of characters and then the overlap between each chunk. So in this example, we set the chunk size about 1024 characters, and each chunk is going to have an overlap of 100 characters. We use the split documents from the text splitter to split the documents into chunks. We print the pages and chunks for testing purposes. This is the code to create a chroma database from our chunks. For this, we use the fast embeddings function to generate the vector embeddings for each chunk. We create the chroma database from documents and provide the chunks and embedding. We set a persistent directory so it creates this database on disk. This way we can load it and use it later. This is useful if you want to use this database in another application such as chatbot, or I may use it in a cloud system. This will enhance the performance of our RAG application. We call the ingest function, and it creates the database and prints the number of documents and chunks in the vector store database. If you are encountering the following error, then this means you need to log into your Hugging Face account. You can create a free account and generate an access token. I will leave the link for the Hugging Face below. The fast embedding uses the following model from the Hugging Face. We need access to it in order for the embedding to function. We authenticate to Hugging Face using the access token. We can create a token on the following URL. We provide a name and select read and write access for this token. Once we create the token, we can copy it and plug it into our code. This will authenticate our API call, and we can use the text embedding model. Let's run the ingest function again and wait for the embedding model to convert our document to the vector representation. We create a RAG chain function that retrieves and processes documents based on user input, using a specified language model and the vector store. We initialize the Llama 3 language model using the chat-ollama class. This model is used to generate responses based on the input and context provided. We create a prompt template. This template defines the structure of the input and expected output. The prompt includes instructions for the model to act as a friendly assistant and to provide answers based on a given context. If no context is available, then it should reply with "no context available for this question." We specify the same embedding and load the vector store from the directory. This vector store will be used to retrieve document embeddings. The vector store is used to create a retriever object. The retriever will search for documents based on similarity scores. It retrieves up to 3 documents with the similarity score threshold of 0.5 and above. A document chain is created using the model and the prompt template. This chain will handle the processing of documents retrieved by the retriever. The retrieval chain is created by combining the retriever and the document chain. This chain will manage the entire process of retrieving and processing documents based on user queries. The function returns the created chain. This chain can then be used to answer questions by retrieving relevant documents and processing them using the specified model and prompt template. We create an ask function that takes the user's input and calls the RAG chain function. We invoke the chain with the user's question and print the answers as well as the sources used. Now we are ready to test this app. We can ask a SQL-related question, and if there is related information in the document, this app will provide an answer based on it. We may ask the question, "How do we check null values?" This will send this query to the vector store. The related information may be present in multiple chunks, but the app will only pick the top 3 results. Once the relevant chunks are retrieved, the AI will decide what is the response to give to the user. So we're not simply returning the chunks back to the users, we're actually using it to craft a more custom response that is based on our source information. It provides a relevant answer and pulls a query that is in the book for us to use. Pretty neat. Let's ask another question. How can we perform wildcard searches? We receive a proper response and sample queries on how to perform wildcard searches using SQL. So this is how we can use the langchain and ollama to create a retrieval-augmented generation app. I'll post a link to the GitHub code in the video description, and you can try this out for yourself and with your own data set. This is all for now. I hope you enjoyed this session. Like, share, and subscribe. Take care, and I'll see you in the next video.